And welcome to this online revision session for AQA FP4, in which we're going to look at the June 2010 question 7 on eigenvalues and eigenvectors. Well, you can see this question is related to 2 by 2 matrices and to the diagonalized form mu d u to the minus 1, where d is formed from the eigenvalues on the main diagonal, and u to minus 1, its inverse, u is formed from the eigenvectors. So in the first part of this question, it asks you to state clearly the eigenvalue and the eigenvector associated with it. So we can see that the eigenvalue in the first entry on the diagonalized matrix is 27. So we can say that lambda 1 is equal to 27. And so the eigenvector associated with lambda 1 will be the first column of the matrix U, which will just be 4 minus 1. And similarly, the second eigenvalue is 1, and the eigenvector associated with that is the second column, which will be negative 1, 3. Then moving on into part 2 of the question, it then says find a Cartesian equation for the line of invariant points of T. Now the key thing for you to know is the fact that the eigenvalue is telling you the multiplication factor that a point is moving on these two lines given by E1 and E2. So if the line has invariant points, every point is staying in the same place, which means the eigenvalue must be 1. And so the eigenvector associated with that eigenvalue is negative 1, 3. And so what we need is then a line where negative 1, 3 and all its multiples of will be on that line, and so that will be given by the line y plus 3x equals 0, because you can see 3 times negative 1 gives you 3, so y plus 3x equals 0 would be the appropriate line. So in part 1 you'll get marks for stating the eigenvalues, and then for correctly matching each of the eigenvalues to an eigenvector you will get an additional 2 marks. Well, actually, sorry, 3 marks. 2 marks for the eigenvectors and an additional mark for matching them up correctly. And then in the next part, you will get a mark for correctly stating the Cartesian equation. And if you remember, we talked about the fact that this was for when lambda was equal to 1, but really we should write down clearly a reason why lambda is 1, right, for a line of invariant points. And that will give you an additional mark in your explanation. So what you are thinking is what you should write down. Into part B of the question, you're now asked to find the inverse of u. So we need to remember to get the inverse, we need the determinant, and the determinant is AD minus BC. So u is the matrix 4, 1, negative 1, 3. So the determinant of this is 4 times 3, which is 12, minus negative 1 times 1. So that gives you 13. So that gives us 1/13 of, and we swap the A and the D round, so that's the 3 and the 4, and the other two entries we change the sign. So that gives us our inverse matrix. Then we've got to find the matrix M. Well, to find the matrix M, we now need to multiply u, d, u to the minus 1 together. Okay, so we know that u is 4, negative 1, 1, 3. D is the matrix 27, 0, 0, 1. And then u to the minus 1 is the 3, 1, negative 1, 4, and it's a 13th of that, so we'll put the 13th out the front of the whole calculation. So working from the right hand end, we firstly got to multiply row by column, so it's 27 times 3, which is 81, and lots of minus 1, so it's still 81. And then it's 27 times the 1, 0 times the 4, so that'll be 27. And then we get 3 times 0, negative 1 times 1, so that's negative 1. And then 1 times 0, 1 times 4, so that gives us 4. So then we've got a 13th of, it's 4 times 81 minus 1 times minus 1, so 4 8s are 32, 324, 325. And then we get 1 times 81, 3 times the negative 3, so that gives us 78. 27 times 4, it's 108. Take away the negative, the 1 times the 4, so that's 108, that gives you 104. And then 27 times the 1 and 3 times the 12, that gives you 39. And then finally we've got to divide that through by 13. And 13's into the 325 will actually go 25 times. To 78 they go 6 times. 104 they go 8 times. And then the last one they go 3 times. So that gives us our matrix M. Well, you get 5 marks. Well, the determinant and the relevant matrix to form the inverse, you get 1 for each of those. And then you'll get a method mark for showing how to obtain the matrix M. And as you work through this, you'll get an accuracy mark for getting down to this point correctly, and then finally an answer mark for getting down to this point correctly. Then into part C, it now says using the first row first column position of m to the power of n, prove that this particular number here is a multiple of 13. Okay, well I think it's a case of doing what they say. Well, we've got to find mn. So we know that mn, well m can be rewritten as the u du to the minus 1. And then we're going to do that to the power of n. And previously in much of your bookwork you will have remembered that this can be simplified down to u to the n, u, d to the n, u to the minus 1. And so we can write down the fact that u is given by this matrix, and d, well, d is to the power of n, and if you remember a diagonal matrix to a power, the entries on the diagonal will be to that power. Of course 1 to the n is just 1. And then you got the u to the minus 1, which we know is 3, 1, negative 1, 4, and then we have to put the 13th out the front. Well, again, we can now start to multiply these together. So again, starting from the right hand end. To begin with then, we got 27 to the power of n times 3, 0 times minus 1. So 27 to the power of n times 3. Well, if we write that as a power of 3, 27 is 3 cubed, so that's 3 to the power of 3n, and then times by 3, so that becomes 3 to the power of 3n plus 1. Then we've got 0 times that entry, which will, when the 1 times the minus 1, so that gives you minus 1. Then we got 1 times that and 4 times that, so that just gives you the 3 to the power of 3n. Not that I think we'll need these. And 0 times this one will just give us, with the 1 and the 4, will give you just 4. Now we're only interested in the first entry. So the first entry will become 4 times the 3 to the power of 3n plus 1. And minus 1 times 1 gives us a plus 1. Then there are 3 more answers here, here and here, but we're not interested in them. Now we know then that that is the first entry in m to the power of n. Now we've got to explain why this number here, okay, is a multiple of 13. So what do we need to say? Well, we need to say that m has got integer values. M has integer values. Which in turn will imply that m to the n has integer values. Well, the only way then that this top value here can be an integer is if it's a multiple of 13, because of this 1/13th fraction that we have here. Okay, so that will imply, therefore, that 4 times 3 to the 3n plus 1 is a multiple of 13. Okay, well, there are 5 marks for this. A method mark for understanding how to find m to the n. For identifying the correct matrix for d to the power of n here, you'll get a mark. Then for obtaining this correct value at this point here, in here, you get an accuracy mark. And then explaining that it's an integer, and that as a consequence for it to be an integer, this must be a multiple of 13. Yeah, and you possibly need to write a bit more than what I've done. I said a lot more than I wrote there, whereas you should write a lot more than you say. Well, hopefully you found that solution helpful. For more help with your revision and your math studies, please go to the Further Math Support Programme website.